Hi, everyone. So I work on behavior and energy issues. And before I jump into my talk, I want to clarify what I mean by behavior. A lot of times when I mention behavior, people think that I am talking about turning on off the lights or TVs when people leave room, etc. But really, behavior impinges on almost everything that we do, at least in the residential and commercial sectors related to energy. So the purchase and installation of energy-efficient technologies, the reduction of energy waste, shifting settings and installing controls, repairing items or performing maintenance, as well as adjusting patterns of use and habits. So for the rest of the talk, I'm going to talk about a project, a pretty large project here at Stanford. We got a grant about 2 years ago from the ARPA-E agency. It's an agency like DARPA, but focused on energy. And we have about 15 faculty spanning 10 departments across Stanford's campus. The departments range from computer science and electrical engineering to civil and environmental engineering, economics, sort of on the one hand, and then on the other we have psychology, communications, education, behavioral epidemiology, et cetera, lots of behavioral sciences. So it's a pretty broad initiative. But the focus of all of the projects are on creating a human-centered system that leverages pervasive sensor and communication technologies to achieve large-scale energy savings. And I should pause to mention, Professor Byron Reeves is the faculty director of the project, and I'm the project director, so the two of us head up this initiative. Okay, so our initiative addresses the following problems. First, billions are being spent for smart infrastructure. Many of you may be familiar with smart meters, home area networks, transportation, and many other sensors. Second problem is that energy efficiency is difficult. Figuring out what to do and how to do it is difficult and boring for most people. So how can we address both of these issues? How can we leverage smart infrastructure to maximize energy savings? So our solution is that a smart infrastructure enables quantification, which in turn enables ways to reduce energy use. So quantification can allow us to provide diagnostics and personalized recommendations to people, to increase motivation through specialized behavioral techniques. So for example, feedback, incentives, markets, competitions, data visualization, etc. And quantification also allows us to create the best programs with improved speed, ease, cost, and scale through objective evaluation of program energy savings. So we can evaluate, and then we can see what works and what didn't, and then we can iterate quickly to improve them. And in addition, I won't have time to elaborate too much on this, but utilities have a lot of money to put towards programs like these, but in the past they've had a very hard time quantifying the effectiveness of programs, and they've been very constrained to certain things like rebates and coupons and haven't had at their disposal a whole range of behavioral approaches that could be used. So it really opens up the toolbox to do this. Okay, so how can we achieve these and other benefits? We're at a unique point in history and have an enormous opportunity on our hands. So we have wireless sensors, like I said, smart meters, home area networks, gas, transportation, hot water sensors, etc., that are becoming pervasive because, in part because the cost has come down dramatically recently. And these sensors enable quantification of energy information. And then we have web-enabled devices, which are now pervasive. This means that web-enabled computers and phones can deliver programs to help individuals reduce energy use. And then in the middle, we have our Stanford engine, which links the pervasive sensors to the web-enabled devices. So our engine is composed of the technology platform in red, which includes sensor and networking improvements, a database, analytics, etc. And then on top of that lives our programs or our interventions. So we have multiple foundational projects that feed into those programs. For example, comprehensive lists of energy actions people can take, segmentation studies, etc., as well as the programs themselves, which include media, policy, and community programs. And I'm going to talk a little bit more about those in a minute. And then in the blue, we have modeling projects, which evaluate the data from all of our programs as well as others to draw inferences about which programs and techniques are most effective in order to inform future work and policy. So we currently have about 20 projects, many of which have collected data and are writing up results for their first round of experiments right now. In Currently, the projects are being developed out independently, but the goal ultimately is to integrate these into a comprehensive solution, which we're just starting to work on this integration right now. So I'm going to jump into telling you a little bit more about the 7 behavioral projects that we have out of the roughly 20 total. So we have a landing page from which we can get to 5 of our 7 intervention projects from that middle bucket that I just described. And you can see the breakdown: media, policy or incentive, and community. And if I click on the upper left, I go to the Power Down project. So this is our simplest program. It's a simple feedback interface. It's a little bit like O-Power type stuff. The data's graphed. You can compare your energy use to your baseline in the past, to your neighbor's energy use. There's recommendations that are given on how people can reduce their energy use, and people are sent emails at strategic times. This is nice because it's simple and it illustrates, from the researcher's point of view, we can manipulate many things in this interface to perform experiments and see what's effective and what's not. We can record click-throughs, et cetera, so we can see how people are using the interface, but we can also see how their actual energy use is changed. A somewhat more interesting project is our Powerhouse game. It's an online game. Here, real-world energy data is incorporated into some of the gameplay. A couple of interesting facts about online games. The audience of the genre is big, with as many as 400 million people worldwide that operate avatars in virtual environments. It's also surprisingly diverse, given that gamers average 33 years old. There's more of them in their 40s and 50s than in their teens. The majority of them have full-time jobs and kids, and the gender ratio ranges from equal to about 3 to 1, depending on the genre. So I forgot to mention the last project, Power Down. Greg Walton in psychology is the principal investigator on that. On this one, Professor Byron Rees in the communication department is principal investigator. This is an up close of a couple of the screens in the game, just to give you a feeling for that. All right, so our next project is Kidogo. This is a Facebook app that allows one to compute their real-world energy savings and then microfinance individuals in developing countries based on their savings. A premise behind this is that the monetary savings that Americans get from reducing their energy is relatively small, so that microfinancing stretches the perceived value of one's money. And this is headed up by Professor Bani Banerjee in the design school. And that last project was an example of one of our policy or incentive type programs, as is this one. So this one also aims to stretch the value of monetary savings and is set up similar to a lottery. So Jim Sweeney talked a little bit about a related project to this one. Both projects are by Professor Balaji Prabhakar in electrical engineering. So this one is focused on home energy consumption, whereas the one that Jim talked about was on transportation. And this is an appliance calculator. This is another project that ties into the incentive type programs. It attempts to address the first cost bias, that people consider the cost of an appliance, but not the long-term energy savings in their purchase decisions. So this app allows one to compute out the savings from any refrigerator currently on the market compared to one's current refrigerator. With the calculator, we can also test various behavioral economic frames to try to nudge people towards more efficient purchases. And this one's headed up by Sam McClure in the psychology department. And then we have our Girl Scout project. So this is our community-based program. It teaches girls about how to reduce energy use, in part by using their smart meter data. So we picked the Girl Scouts. It might appear, oh, that's cute, but it was actually a fairly strategic decision. They have very high penetration. 1 in 2 women in the United States have been a Girl Scout with an average duration of about 4 years. And how many people in here have bought Girl Scout cookies in the last couple of years? Okay, so there you go. So we've run the program in 30 troops. About half the troops focus on reducing home energy use, and the other half on transport and food energy use. A troop means there's fun activities for the girls to learn how to reduce their energy use, and at the end of the lessons, the girls act as reporters and create a video telling others, including their parents, which they really enjoy, how to reduce their energy use. The videos are then posted online at the program's website, shown here, for their families to view, which draws the families into the website. And although we didn't have this in the first implementation and evaluation of the program, the goal now is to integrate some of the other projects onto the website so that when the parents go there, they have access to the other programs and we get higher penetration for those programs. And this project is headed up by Professors Tom Robinson at the School of Medicine, as well as Nicole Ardoin in the Department of Education. And on the right, you can see the badges associated with the program if you went through it. Okay, so this is just the energy services platform that supports all of those projects. So this was actually a project in and of itself to create a platform to support them where we could do experimentation, et cetera. And next I want to give you, so I mentioned at the beginning that the projects are currently independent, but the hope is to integrate them. So to tie things together for you, this diagram illustrates one way that you can that they might be integrated. So at the top, we have engagement channels. We know from other efforts that only about 0 to 4% of utility customers actually go to an energy website that the utilities advertise. On the other hand, environmental community-based programs sometimes get as high as about 85% participation in communities. Thus, we see community programs like the Girl Scouts, as well as online social networking sites like Facebook, and you probably noticed that some of our apps were Facebook-oriented, at the top, playing a strategic role in channeling folks to a web-based recommendation system, which provides diagnostics about whether you, in particular, should get a retrofit, replace specific appliances because they're inefficient or malfunctioning, etc. And I'm going to expand on that a bit more in the next slide. Then these diagnostics allow us to channel you into specific programs and incentives that make it easier for you to take action. Motivation can be increased to revisit the system for more recommendations through novel incentives or media that make specific use of the data. So when I went through all the projects, you might have noticed that each of them actually make use of the sensor data in a different behaviorally oriented way. And this allows it, sorry, I lost my place. Right, okay, so finished up that point. And then changes in energy use data are then used to evaluate and improve the programs and improve targeted marketing and improve program evaluation for utility credits, which I described a little bit at the beginning. So I said that for that middle piece, the personalized diagnostics, I would expand a bit. So we have 3 of our projects focus on energy disaggregation. So disaggregation allows us to take a whole building or an aggregate energy signal and separate it into appliance-specific data. In other words, plug level or appliance level energy data. A set of statistical approaches are applied to accomplish this. So you don't need additional hardware. You can take data from the smart meter or one other central place in the home. So we have about 3 projects that work on this, and we're actually also collaborating with a commercial vendor to integrate so that in the commercial space, we can pull in disaggregation into our various programs that I described today. And last, I just want to acknowledge our fabulous team across the many departments here. Thanks.
Do you have any, I don't know if the smart grid is smart enough to do that, but I think on campus we have kind of free electricity, so we don't pay according to our use. Have you ever think on like having a program on campus to measure individual use of energy?
Right. So the question had to do with on campus, energy is free for people. And so if we had a behavioral program that looked at how we can motivate people in the context of it being free for people. So a couple things about that. We have done a program a few years ago. We tapped into, there's a conservation cup competition on campus every year during winter quarter that for both energy use and water use, where the dorms and frats and sororities compete against one another to try to reduce their energy use. So we've evaluated that, and they do indeed get energy reductions during the competition time. We've also layered on a couple of things to look at whether additional behavioral approaches can make a change. We did not find effects for the additional techniques that we used, but it may have been we didn't have enough power based on the way we set up the study. The other thing that I'd mention is that there are environmental groups on campus that are both associated with those competitions and separately that are looking at feedback in the dorms and have tried out some feedback devices in a couple of the dorms. Yeah. Yeah.
Know the effects which you just described to make up this competition was over?
Yeah, so persistence, that's a really good question. So we haven't run our projects out long enough yet to look at persistence. We have a project next year to look at that. But on pure feedback, without any of these sort of interesting techniques, just sort of providing a display to people and giving them feedback on their energy consumption, there's actually been about 45 studies done over the past like 30 years in various countries, including the United States. And probably, I think about 11 of them, as of about 2 years ago, about 11 of them have looked at persistence, and about 9 of them have shown persistence after the feedback was stopped. I take back the part about us not doing. We actually have looked at it in at least one of our studies. We did a collaboration with Google where we did look at that same thing. And for us, the effect diminished but didn't go away. So we went back down to, I think, like a 2% reduction compared to pre-feedback in energy use. So that's pretty small sustained reduction, but others have reported larger sustained reductions. So anyhow, if you're interested, I can point you to the literature and you can look more closely. Yeah. Yeah.
You mentioned the market size for gamers, 400 million. For Powerhouse, what's the target market for a game like that? And then what's your adoption rate? Is it above or below it? And the same question for Kidogo as well.
Okay. I wish we had 400 million. I don't think we're going to get up to that. So most of these projects, when the experimenters, the researchers started them, they were interested in primarily doing them as research studies and small-scale field trials in the real world. The hope was that eventually we'd scale it up to be quite large, but we ran into data collection issues at the beginning and stuff that have slowed us down. So anyhow, in summary, so far for Powerhouse, so we have a broad spectrum. So some of our studies, like Powerhouse, so far data's been collected in, say, up to about 200 people. And some of that's been in lab-based experiments, and some of that's been based in real-world situations of recruiting people in the real world. At the other end of the spectrum, the lottery-based stuff that Balaji Prabhakar has done, he's had participants from about 5,000 to 10,000 people. And the appliance calculator, we attract people through Google AdWords, and we've gotten over about 30,000 people into the appliance calculator. So it ranges a lot, and also both in numbers and in where the different groups are as far as scaling it out large scale. We do have 2 projects that we're going to be doing this coming year. So I mentioned the integration piece. So I'm particularly interested in scaling out, integrating the best pieces, tying them together, and then scaling it out large scale. And so we're working on that now, and we do have 2 projects next year with utilities to test it out in populations of about 1,000 people each. And then if that's successful, the idea is to scale it out to the rest of their customers and kind of grow out from there.
Do you see the broader research agenda, the collection of this really rich data that you're after, and kind of what you wrote about in your American Economic Review article about decision values, how we represent different things? Do you see this broader research agenda as a way to, or do you think that there's a way to integrate it into standard economic theory, or do you think it would be kind of a, like parameterizing different variables that have traditionally not been considered? How do you, what do you see as the end goal of all this research that you're working on?
For me, the end goal is to have deep, widespread impact to really reduce energy use. And that was our original program director is here in the audience, and that was the original goal of our proposal when we wrote it. So I'm still after that. It sounds like you're after the econ modeling side, which is also an important piece because it's used in policymakers making decisions, which can have an impact on whether these things can get scaled out, et cetera. So for that piece of it, I guess one important piece of these programs is to quantify the impacts of the various programs as well as the various techniques, because like you said, the quantification, right now, and Jim talked about this too, right now we don't have enough of an understanding of the magnitude of these impacts to really build them into models and see what things are worth building in and how much impact there is. And to address there's other aspects of modeling that maybe veer from the economic modeling more in segmentation that I think can be used for targeted marketing that wouldn't be directly probably related to your interest, but would be very important. Another piece of it that's important that may be more related to the econ side is quantification for utilities. So right now there's a lot of money and time and legal back and forth is spent between utilities and public utility commissions to quantify the impact of programs. And there isn't a set methodology to do that. And so one of the things that we're working on is integrating into the platform that we've built a more mechanized way of doing that to make that easier. I think that's really key in opening up a lot of these programs for use and et cetera. And then another piece that relates to modeling, related to the question that you asked Jim earlier, in the way to represent multiple agents. There are people working on multi-agent simulations. We had one project on our team where instead of having like one agent represented in one way, you can have multiple types of agents and also model their interactions. And so that way you can look at diffusion processes and see what sorts of things influence diffusion, because that's kind of a very different, if you model each actor individually, you're not capturing the norm effects and also different structures, social structures, and how things can diffuse more easily in certain structures than other structures, et cetera. So that may be a piece, although the traditional econ community is not, from what I've heard, isn't as hot on the multi-agent simulation type of stuff, but maybe a combination of techniques might be interesting. So anyhow, feel free to come talk to me another time. We can talk more.
I have a question about smart meter usage and the implementation of that technology.
Sure.
I think it's wonderful in terms of, average home users can actually track their own usage in real time, see how it kind of breaks up, see, how can it be more efficient. But I found that the implementation is kind of limited. I come from Florida, and I was trying to get the local power utility to be interested in that, but they said it was just too many hurdles, it's part of that. So I think it's a wonderful technology, but what are the difficulties in actually getting it out to the public? Because I can imagine it's not easy.
Yes, we spent a lot of time our first couple of years working on this. Okay, so in California and Texas, basically every building in those states have smart meters at this point. In Texas, so we think that disaggregation, getting this appliance-specific energy use, is really important. Right now, the energy data that goes from the meters in all of these homes, commercial buildings, whatever, go back to the utility first. It's hourly data, and then you can see your data like on a website or whatever. You can't really use hourly data. You can't really run those algorithms and get good appliance-specific energy use on the hourly. You need more like 10-second data. In all of the meters in California and Texas, you can get 10-second data, but the utility has to activate it. They've done this in Texas, but they have not yet done it in California. They're working on it. They're doing pilots. They plan on doing it in the next year or two for everybody. But there's some potentially security issues with not with sending that 10-second data, but doing other things that they had intended to do, like sending data back from specific appliances through the network or controlling devices in the home, et cetera. So it's taking, there's a bunch, you seemed interested in the nuances, and I'm happy to talk to you more later. There's a lot of them. There's a lot of nuances as to why it's taking longer and what form is the data in and how is it going to roll out and stuff like that. But I anticipate that in just looking at the maps of projected smart meter diffusion of states that have already opted to install them and that are in process, as well as other countries, because there's many other countries that have done it as well, we're going to have access to many, many, many people that way. And then there's other sensors that are becoming pervasive as well. So for example, Progressive Insurance gives people transportation sensors and lowers their rates based on those transportation sensors. We could use that data for energy data. There's grocery store. Every time you scan items, grocery store has data on everything you've purchased. That's interesting data. So there's lots of other types of data that we can expand out just from the residential home energy use into these other areas. So I think it's a pretty promising domain. Yeah. It ends up, I'm out of time, but feel free to get in touch with me and come by my office and we can talk more. Send me an email.